Now we've just taken a look at theta, the 1706 example. This is part 2, and I'm going to show you the same example, but this time we're not going to start out just by finding the square, completing the square. We're going to solve from the start, which means we're kind of going to do both at the same time. So I'm going to make that equal to 0, and my first act will be to get rid of the 5, and so it's going to be an x squared here. And to do that, what I'm going to do is, rather than to factorize the whole thing, and I could do that, and hey, look, that worked out perfectly well here. That was the approach we took. But this time we're not going to do that. This time we're going to go and solve from the outset, and it's probably a better approach if you are going to solve to do it this way. So my first step really is going to be to say, well, let's get rid of the 5, and to do that, we can just divide everything by 5. I'm going to divide this by 5, this by 5, this by 5, and importantly, this by 5. 5 divided by 5 leaves me with an x squared, so I'm going to put that implies that. This is going to be plus 8x on 5, and this is my 1/5. Now, you'll notice, of course, at this point, we don't have any brackets, and that just simplifies the process a little bit. So, next step, I'll put that implies that. So I'm going to have my x squared plus 8x on 5. I'm going to subtract 1/5 from both sides. Subtract 1/5, subtract 1/5. So now the negative 1/5 is now over here. Now I'm going to add the b portion. So I'm going to add an 8 on 5. I'm going to multiply it by 2, so 2 lots of that. I'm going to square it, and I'm going to do the same thing to both sides. Now this time, I'm not going to subtract it from over here. I'm simply just going to add it to over here. So it's balanced. We got added it to here, we added it to here. The only reason we subtracted it in this version over here was because everything was on the same side. Because if we add it to that side, we've got to subtract from that side, and the net balance is 0. Here, it's now on the other side, so I add it to the side. I'm going to add it to the other side. It's going to be 8 on 10 all squared. So let's simplify that as we go along. So we've got that implies that x squared. In fact, what I'm going to do is I'm actually going to simplify this in one go and just make that x. This is going to be 4 on 5, and I'm going to go plus 4/5. There it is. Square it and make that equal to all the stuff on the other side. So this is now negative 1/5 plus, and of course this is 4/5. I'll say 4/5 squared. There we are. That makes life easy. Okay, now let's simplify that. So it's x plus 4/5 all squared is equal to, I've got negative 1/5 plus, and I'm going to square that. It's going to be 16 on 25. And again, we can do exactly the same thing we did before, which is to multiply this by 5. So that now becomes 5. Multiply this by 5, that becomes 25. And of course, now I can add 5 and 16 25ths together rather nicely. And this time we're going to have 16 25ths minus 5 25ths, which of course is just 11 25ths. So now I've got an x plus 4/5 all squared. Now I'm going to find the square root of this side, find the square root of this side, add my plus and minus. So I've got x plus 4/5 is equal to, and again, I'm going to say this is going to be root 11 plus or minus root 11 on 5. Now I'm going to subtract my 4/5 from both sides. Subtract my 4/5, there it is, leaving me with an x, and suddenly I've got 4/5. It's a negative. I've got a plus or minus. I've got a root 11 and over 5. And now I can simplify by just saying equals negative 4 plus or minus root 11 and all over 5, just as we had before. So essentially, we've got the answers x. So we can say either x equals negative 4 plus root 11 on all over 5, or x is equal to negative 4 minus root 11 all over 5. And you would just go ahead in the usual way and solve that and come up with two decimal answers. But nonetheless, I think that's probably, if you've been told you're going to solve, and you know you're going to solve if the whole thing is equal to 0, I would tend to do it that way myself. But knowing how to use both is useful, and hopefully that makes some sense. Let me know.